This is my automatic dog feeder produced for SER 202. My dog feeder is currently being powered by USB power, and there's also an external power supply for the control of the servos so that the battery life of this machine lasts longer. This 9-volt battery here can also power the board when it's not connected to the computer. This here is the 1 kilogram load cell, which is connected to a HX711AD module, which converts the load cell into a format that the Arduino Mega can use. So this here is the Arduino Mega 2560. On this particular case, it's got a prototyping shield on the back of it to make all my connections to different various components a lot easier and neater. So to call the dog to make a sound, here has a buzzer on it. This is just a standard buzzer module. It will call the dog playing a different tune for each dog. To feed the dog, there's a container here which will be filled up with dog food, as saw on the demonstration day. And then under here there's a servo which open and closes this flap here, and that will let food flow out when the time's necessary. And this flap's just attached on here, and there's a cutout here also so that the servo can be taken out, so this whole project can be disassembled and changed around if necessary. So I'll plug in the project now and you can see it running. So that was just the call for the small dog. So I'll have this water bottle here to simulate the small dog weight, and it's opened and closed as you saw. Also on my computer monitor, it reads the weight of the dog, and it says there that it's just picked up the weight of the small dog at 123 grams. So that was the small dog call after when it was turned on. So 50 seconds in, the small dog will be called. Then 90 seconds in, the big dog we called. So we can wait for one of them. So that was the small dog again. And as you can see on the screen, it sensed the weight of the dog at 182 grams. Now that weight is actually sensed over a period of 25 milliseconds, and it takes 5 readings and then it averages those readings, so that if there's a small fluctuation in the weight of the dog, then it'll still measure it anyway. Now on this prototyping board back here, there's a red button at the bottom. There's also a black button down here as well, and then there's a reset button just here. So the red button is what I call the emergency stop button. It will close off the chute so that nothing can flow out of the bottle. And then the black button is basically a clear feeder button, so it opens the chute. And then this small black button up here resets it. So as you can see on the back of the prototyping board here, there's one wire comes in from the load cell, so they're all cabled together, and there's headers there close together so that the cables all go into the same spot nice and neatly. So this little header here, this goes to the buzzer, which you can hear up there, and then this third connection here goes to the servo here, which controls the feeding process. There's also a set of pins here which can be used to connect external buttons that do the same thing as these open and close buttons. So I'll test out the open button. So that you can see in here that the servo has opened, and then this is the close button being pressed. So as you can see, red button closes, black button opens. for the actual construction of this, it's been made mostly out of laser cut material, so it's all out of 6mm acrylic, and it's been laser cut to shape to fit the specific components. These holes here have also been countersunk and use countersunk bolts, so as you can see that's smooth, so if the dog puts its paw on it, it's smooth. Also underneath here on the bottom, I've done the same thing, so they're flat on the bottom so the base sits nice and firmly on the ground. As you can see here, this chute, so that's the actuator that controls the flow of the dog food. It's sandwiched between these two pieces of 6mm acrylic, so the bottle is always positioned exactly above this chute so that the amount of dog food can be released exactly. This schematic here shows how all components are connected to the Arduino and to various power supplies. This is the code used to program the microcontroller to perform tasks for the dog feeder. This first section of code shows the setup for both the tunes, the load cells, and a few global variables. In this setup function of the code, it sets up the buzzer, the timer to control the whole system, the servo, and the load sensors. In the main loop program of the code, it runs through and checks every 50 and 90 seconds, and when those times have elapsed, they'll either call the small dog or the big dog respectively. The small dog routine and the big dog routine are basically identical, apart from the small dog routine senses the weight of the small dog and the big dog routine senses the weight of the big dog and feeds them accordingly. There's a print time function that just prints the time for use for debugging, and there's a feed small dog function which feeds the small dog, and then a big feed dog function which does the small dog function twice, so the big dog gets twice as much food. There's also simple functions as close and open servo just to make the code simpler to run. There's two call functions, so the big dog and the small dog call function, they make the sounds to call the dog to the feeder. There's also a get weight and a print weight function that reads values from the load cell every 5 milliseconds to get an average over 25 milliseconds. Here there's also some interrupts, so there's an interrupt, one for each button on the board, and then there's also an interrupt for the timer. And then these down the bottom here is for the serial communication, which allows it to talk to the computer. Thank you for watching my presentation.